question regarding the practice exam for Unit 3 in Math 1325. I am navigating here to the practice test. There we go, there's the right tab. And the first question was regarding 13.2, problem number 23, which appears as question 3 in the practice test. And you can see each time you click on it, it cycles through a variation covering the objective where we see a rational exponent. And so the question was, how do we take the derivative of this function? So that's a good question because it says find all x values of all points where the function has relative extrema, and then find the value of the extrema. Because we are talking about extrema, we want to use the first derivative test. We're going to figure out from the derivative where our function is increasing or decreasing, and if we can figure out where it's increasing then decreasing or decreasing then increasing, we can determine if we have a relative max or a relative min, and that will be further clarified with the follow-up question, which refers to question number 10. So here I am looking at number 23 from 13.2, and you'll notice that this means that it follows exercise 23. So what I've done is at the top when I was clicking through, I had opened up my e-text, so I go to the Pearson widget. For a student, you'll only see this left-hand side. You'll click the e-text course home. That's loading, I already have it open. So I'm going to go to the e-text, click on the e-text screen. I actually already have that open. I'm going to navigate in my textbook to where the page number has the exercises for 13.2. So for this one, 13.2, exercise 23, if I scroll down, it appears here. And I can click on this little button here that looks like kind of a broken pyramid. I open that up, it says, oh, I can look at my exercise set, get some help actually. It's not tracked. I click on exercise number 23, it's letting me try it, and it says, hey, here's a similar problem. Notice again it's got these rational exponents. If I want help, I can do help me solve this or view an example. It'll walk me through it, so just if you weren't aware of that, please be aware that that's there. And it's a very similar problem to the one that you saw on my screen. So I'm going to go back to actually my practice test. Let me find the right tab there. There we go, finally got it. There's the right tab. So here's my practice test, and I've gone ahead and I've worked out this particular problem. And so what you'll see is I've looked at the function. I know I'm going to find the extrema, so that means again take the first derivative, and then I've got to find critical numbers, which means I'm going to find where the first derivative is equal to 0 or where it does not exist. So I'm going to take the derivative. When I take the derivative of 16x, I just get 16. And then here's, I believe, where there was some confusion. All I have is a power rule. So I'm going to take the power, which is 16 over 19. I'm going to multiply it by the constant, which is 19, or the coefficient. I'm going to rewrite my base, which is x, and then I'm going to subtract 1 from the power. Now the only thing that gets tricky here is these are rational numbers. I have some fractions here, and so I've shown my work, and you can pause it here. I have that 19 over 1 would multiply by 16/19, okay, do some cancellation. And then when I'm subtracting 1 from 16 over 19, I have to get a common denominator. And so when you see I've simplified this, I get 16 plus 16 times x to the negative 3/19. When I have a negative exponent, I can rewrite it as you see down here in this portion. And I've noticed that when I rewrite it without the negative exponent and using positive exponents, I can see that my derivative will not exist when I have a denominator equal to 0. Well, what would make the denominator equal to 0? Well, if x itself was equal to 0. So that right there is going to be a possible critical number. And so that, again, is where f prime doesn't exist. And then I also find where f prime is equal to 0, because that will also give me a critical number. So what you do is you set the derivative f prime equal to 0. So I have 0 equals 16 plus 16 over, and it is x to the 3/19, but I can rewrite that as we remember in our prerequisite material. I take the denominator, which becomes what's called the index of the radical, so I've got the 19th root of then x cubed, so the 3 came from the numerator, and then I'm simply solving an equation here, and so I'm going to multiply both sides by this denominator. So here you see me multiplying both sides by the denominator, which then leaves me as the 19th root of x cubed times negative 16 equals 16. So I'm trying to isolate my radical here, and so I'm going to divide both sides by negative 16. When I divide the right-hand side by negative 16, I get a negative 1. Well, how do I isolate my radical? I raise it, or both sides, to the power of the index. So if I've got the 19th root, I'm going to take everything to the 19th power. Well, that's not too bad. It looks worse than it is. That will end up giving me my x cubed, right? I take and I go 19th power of something to the 19th root. I just get back what's called the radicand, the stuff under here. And then if I raise negative 1 to any power, it's either going to be negative 1 or positive 1. Well, because 19 is an odd number, that means that I've got negative 1. And so I get x cubed equals negative 1. Well, that means x is equal to 1. So here I've determined that my two critical numbers that I'm looking for are 0, and again that came from where the derivative did not exist, and negative 1. And so what I would do is I would then plot those on a number line, and I would test to the left and right, and I would determine if I've got a relative max or min, and I would see that by whether it's increasing or decreasing. But I think your question, or the question I had, was more about taking the derivative. So let me kind of follow up about the part of actually doing the first derivative test, which came about, go to the next screen here, which came about when asking for what problem number 10's solution would be. And problem number 10, let me go to my other screen here, and you'll see that perhaps, okay, there it is, problem number 10. It says find the relative extrema. It gives a function called capital G, and it says find where the relative max or relative min is. Well, all I have to do is that first derivative test and determine if it's a max or min. So I'm going to pull up this problem, resize this just for a moment for ease of viewing. When I'm looking again for relative extrema, I'm going to find my critical numbers, which is going to be by taking the derivative, determining where the derivative does not exist or where it's equal to 0. When I take the derivative, and this is just using power rule, so not very difficult, I get that g prime of x is 3x squared minus 6x. This is a polynomial, and polynomials are continuous, which means the derivative is going to exist everywhere. So I'm not going to have to worry about finding where the derivative does not exist, because that just doesn't happen with a polynomial. What I do have to worry about is finding critical numbers from where g prime is equal to 0. So you can pause here for a moment if you want to catch up, but I will take and I will set it equal to 0. 0 is equal to 3x squared minus 6x. I do a bit of factoring, factor out the GCF, which is 3x, and I would determine from here that the only way two things multiply to become 0 is if the first factor is 0 or the second factor here is 0. So we get 3x equal to 0, or 0 must equal x minus 2, that second factor. I solve and I get two critical numbers. And so I take x equals 0 and x equals 2. I plot them on a number line. So my number line's drawn. I plot, I put 0 and 2, and then I determine I must test my derivative on either side of these, or within these intervals. And it kind of cut off here on the page, but what I like to do is I like to rewrite my factored form of my derivative. So what this should say is g prime of x equals 3x times the quantity x minus 2, and that's what I plug into. So if I go below here and I've kind of set off to the side what I'm testing, I pick a number to the left of 0, so x equals negative 1, and I go to the factored form and I say, well, if I plug in x to be negative 1, I would have 3 times negative 1. Well, that's a negative number, so it gives me negative on the outside. If I plug in x to be -1 within the quantity here, I get -1 minus 2. Well, that's a -3. I don't really care what its value is, but I have then on the outside I had a -1, on the inside I had a -3, so negative times negative makes a positive. Well, if my derivative is positive, then that means that my function, g, is increasing. And so I can say increasing. What does that mean? If I start drawing it, it's increasing. Okay? Well, now I have to test that next interval. If I test x to be 1, on the outside of my factored form, 3 times 1 is positive. In the quantity, if I plug in 1, I have 1 minus 2 is a -1, so I have on the outside positive times negative. Well, I get overall that my derivative would be negative, which means that my function would be decreasing. So I think about what that means. On one side, on that interval to the left of my critical number x equals 0, I am increasing, and then on the other side of it, in the next interval, I am decreasing. Well, if I draw that, it's kind of easy to see. That means that I would have a relative max here. And so my maximum would occur at x equals 0. Now to determine what the maximum is, I actually have to plug in to my function g the value x equals 0. So I would find g of 0, and that would give me the maximum. So I know it occurs at x equals 0. So notice there's a difference. It occurs at x equals 0. Well, the maximum is the y value, or what would be g of 0. Okay, same thing over here. I've already done this middle section, so I'm going to move to the right and test something to the right of 2. Well, 3 sounds great. So I go to my factored form, and I think about what happens if I plug in a 3. Well, that would give me a positive on the outside. If I plug in 3 over here, I go 3 minus 2 would give me a positive 1. So I get a positive times positive, which is, of course, but I left it off, a positive, which means my derivative is positive and my function is increasing. So again, we had already known that on the first interval to the left, I was decreasing, and then as I move to the right of 2, I am increasing. So if I think about drawing that from the left, it's decreasing, from the right it's increasing, I've got a minimum. Again, the minimum occurs at x equals 2. What is the minimum value? Well, I actually have to evaluate the function, the original function, g here, and find g of 2. So I hope that that answers your questions. Please let me know if it does not. It probably took me longer than I anticipated to explain those, but hopefully you have a good grasp and you can always replay this.